That sounds great.
So we're recording now. And welcome everybody. This is another webinar from the Instructional Design and Learning SIG. Today we're going to hear from Adam Bradley. He's going to talk to us about the foundations of technical editing. Adam comes with a great resume. He's a senior technical writer and graphic artist. He works in the DoD environment doing aerospace documentation. He's got a Bachelor of Fine Arts in Industrial Design from Savannah College of Art and Design, which is called SCAD. That's an interesting acronym. And a Master's of Business Administration from Georgia Southern University, GSU. And right now he's working on a Master's of Science in Information Technology and Business Intelligence and Analytics from Purdue. And he is telling me that he's getting ready to graduate in the spring semester. So congratulations, Adam.
Thank you.
Yeah, he's Adobe certified expert in Adobe Illustrator, Creative Cloud, and project management. And he's a project management professional, so he's got a certification from PMI. I can't wait to hear what he's got to teach us. So Adam Bradley, you have the floor. Thank you so much for presenting and sharing.
Oh yeah, thanks. You're welcome. And please let me know if any questions come through the chat. I'm not gonna be looking out for them while I'm going through everything, and then I'll have some time set up for the end to be able to discuss everything. So again, this is for foundations of technical illustration. Move on to next. So thank you for giving the introduction. Pretty much what I have on this slide. The only additional thing is that I do work for Mantech. They're a phenomenal company. And so if you are looking for work, please, I recommend checking out mantech.com careers. And if you feel like you're qualified for any of the positions that you're seeing, please feel free to reach out to me after this webinar, and I'll be happy to do what I can to refer you. So the purpose of this is to discuss the foundation of technical illustration. So there's a lot of different ways to be able to communicate. Technical illustration is just one of them. And it's important to be able to understand all the different mediums and forms of communication, because a lot of times within documentation or just in general within communication, it's very easy to lean on just writing. And a lot of times writing will be the best form to be able to communicate. However, there are a lot of other things: videos, photography, physical prototypes. And then with technical illustration, you could do 2D drawings or 3D drawings in CAD models. And these give you additional benefits, right? They're different mediums for different purposes. And so if you're going to be trying to communicate something that's more tangible, more physical, usually using a visual to be able to communicate that is going to be more ideal. So for this, again, we're going to be talking about technical illustrations. And the reason you'll want to use these beyond other mediums is if you're trying to communicate something technical, but a lot of times physical, or can be represented within drawings. And for example, photography can do a great job, right? You can quickly capture an object, a prototype, but with technical illustration, you can do a lot more. You can end up doing cross sections of it. You can show exploded views of that. You can fade everything out in the background, and you can just focus in on that button. So there's a lot of things that just a basic picture will not be able to capture. Yes, you can do manipulations. You can edit in Photoshop and highlight different things that way. But technical illustrations will give you a lot of options that you won't see with photography. And a lot of times photography will be the best option or best medium if it's trying to present just exactly what it looks like. Videos, right, you get the benefit of time being brought into it. And then with physical prototypes, you can actually test something out that's physical. Is it possible we can mute some of the background noise? So types of technical illustrations. Well, you have technical illustrations, so 4 types: drawing on the left, right? You can do hand drawn, you can do wiring diagrams, you can do cross sections and part analysis.
Just a second. Could you please advance the slides? Nobody's seeing
Oh, you're not seeing the slides?
on the first slide here. Thank you.
That's weird. Sorry. Let's see why that's.
Can you shift to slide view?
Yeah,
Slideshow.
we're seeing presenter view, not
Okay.
slide view.
Let's see if I try this.
Ta-da!
Okay. Now, are you seeing slide now?
Yes, perfect. Thank you so much. Sorry about that, Adam.
Yeah,
Thank
I'm sorry. I didn't realize you guys weren't seeing the slides with me. I apologize for that. So this was the slide that I was just describing about the different types of writing, photography, video, so technical illustration, and so forth. And now the types of technical illustration. So you got types of drawings. You can draw things in different views on the computer. You can do hand drawn. You can do wiring diagram. You can do cross section and part analysis. You can do figures for trying to show procedures right. This kind of is really nice. You can do this also in a video, or you can do this in written format as well. But with this drawing, you quickly at once get a glimpse of what you're trying to show, and you can create a storyboard or a time lapse. You can do infographics, able to visually represent something really quick. And then you can end up using 3D models, components, and parts to kind of show operations and how things actually work. And then additional ones, you can create organizational charts, cover graphics, journey maps, or even graphical user interfaces for apps. So again, there's a lot of different things that you can do with technical illustrations. There's a lot of different purposes. All it is to be able to try to communicate your idea within a visual manner. And obviously having some type of technical aspect towards it or involved with it. So something that's important to understand for graphics is vector versus raster. And so you have vector drawings, which you can kind of think about as if you're typing in Word. So if you're typing words in Microsoft Word, you can change that to 2-point font. You can change it to 80-point font. You get no pixelation. You can easily backspace and type something new. And it's because it knows what everything is. It knows the polar coordinates. Is basically a mathematical formula. If you take a screenshot of that Word document and then try to expand that to 80-point font, it's now capturing all the pixels and is trying to duplicate those pixels as it's expanding it, or it's just changing the size and keeping the resolution the same. And when that occurs with a raster object, because that's what that screenshot is, that's the same thing as a photograph. So that's why with vector objects, it's usually easier to edit. It's easier to manipulate. You have different nodes. You have different line weights. You have different layers and elements and things that you can move along it. With raster images, if you're using Photoshop, yes, you can have layers. You can make certain things that you can manipulate and edit, but it's not as easy to edit. And it's going to have a resolution that is going to be confined with the drawing, whether it's 300 dots per square inch within a certain size parameter, or 150. There's going to be those dots per square inch that are going to define that resolution. With vectors, you can scale it to a skyscraper. You're not going to have any deterioration. And that's why a lot of times Not always, but a lot of times vector drawings will be a smaller file size compared to a sharp raster image. When you're doing vectors and rasters too, you can draw this into a vector and you can then print it. You can, as I said, you can take a screenshot of it. You can make it a raster image. The vice versa is very difficult. There are programs out there such as Adobe Illustrator that will grab a raster image, such as this photograph with my wife and I when we went to India, and try to make it a vector object. And it's basically going to be looking at everything and it's going to be trying to retrace it as vector elements. The vector elements unless it's a very simple drawing of a black and white icon or something in that nature, I've never seen it do a really good job. It's never been a clean, easily editable, highly accurate conversion. Typically, what you'll have to end up doing, again, unless it's a very simple drawing, you're going to need to end up retracing or redrawing it if you want to make it a vector object. So it's very easy, again, to go from vector to raster. Raster to vector is usually a lot more complicated. So when you apply colors, you have RGB, CMYK, HSB, and then hexadecimal. So RGB stands, you can see it right here, red, green, blue. And the highest value is 255. The lowest value is 0. RGB is usually used for screens, displays, things that make light. And it's an additive process, right? So the more of red, green, and blue I add, so if I add the full values of red, green, and blue, right, I get white. That's all the colors together. You have 0 values in red, green, and blue, you get black or no light. And then you have CMYK. So CMYK is used for printing, and it stands for cyan, magenta, yellow, and then K is black. And you some printers will like to only use 3 CMY. Usually you do want to use the black ink if you want basically darker colors. This is going to try to basically create those darker colors of the CMY. If you want them to look better, usually having the K value is going to be helpful for your printing. So usually with most programs such as Photoshop, Adobe Illustrator, it's going to let you set it. It's going to say if you want to be RGB or CMYK. It's a good idea to do that depending on your intended output because the colors are going to look slightly different. And it's going to basically be presenting the colors based off of whether it thinks it's going to be CMYK or more for print output versus RGB for display or light. Then you have HSB. It's not a mode, but it's an easy way to be able to manipulate color. So it stands for hue, saturation, brightness. Within Adobe Illustrator, it's a scale from 0 to 100. And that's the same thing with the CMYK. Again, Adobe Illustrator, it's a scale from 0 to 100. And lastly, you have hexadecimal. And so the hexadecimal is basically trying to represent RGB. So the first 2 values are R, second 2 values are G for green, right? And then last 2 values are B for blue, and it has a scale. There are 16 characters for each one of those, going from 0 to 9 and then A to F. And as you can see, if you make it all Fs, you get 0. Or sorry, if you make it all Fs, you get white. And if you make it all zeros, you would end up getting black. And usually the hexadecimal colors is used more in web design or for coding to be able to just tell the program what color it is instead of having to separate into 3 different values or 4 and for the CMYK stands. So now when you're creating drawings, you have orthographic. So you can end up creating everything in a cube. So whether it's a drawing of the safe, whether it is a sphere or a cone, whatever it is, it can be drawn inside of a cube. And it's usually easiest to be able to measure everything out using a cube. And all cubes have 6 different sides. So you have top, left, front, right, bottom, and back. These can be different. Usually these are the different orthographic views that you'll be presenting drawings from. And when you're doing it this way, as you can see from the safe, the side view and the top view and the back view, it's just a straight on shot. It's a straight view. There's no warpage, there's no perspective. It's just that view, and not seeing any sides, anything at an angle. Then you have perspective, where you obviously are seeing an angle, and there you have warpage, things are going, vanishing within the perspective. So within perspective, you have vanishing points. So as you can see here, you have vanishing point on the left in this example, and then a vanishing point on the right. And then you have the horizon line. And usually that's going to be around where your eye level is. So as you can see here, as things are getting closer to that vanishing point, it's vanishing over on the left. And as things are getting closer to that vanishing point on the right, it's starting to vanish or warp as it's going into that vanishing point. So you have bird's eye view when you're looking down at an object, street level view when you are basically at its level, you're not above or below it, and then worm's eye view when you're looking up at an object. So you have, for the most part, 3 different perspectives: 1-point perspective, 2-point perspective, and 3-point perspective. Now, technically there are 4-point perspectives, and then if you want to do more, you can go 5 or 6. It's very rare that you'll ever see any drawing above 3-point perspective. And again, as you're adding these vanishing points, you are adding warpage, right, to the drawing. Things are vanishing, they're getting smaller as it's getting closer to those points. So with 1-point perspective, everything is vanishing into that single point within the drawing. And then again, representing everything as cubes or rectangles because everything can be drawn basically inside of a box. And you can use those boxes to start measuring everything out. So now you have 2-point perspective. For these examples, I did a 45 degree perspective cube and then a 60-30 degree perspective cube, because those are just visually, a lot of times those are the ones that you're going to end up using. If you want to use 2-point perspective visually, they just look nicer. Those are good angles to be able to use for 2-point perspectives. So you can see over here, again, everything is vanishing to the point on the right, everything is vanishing to the point on the left. For the 60-30, same thing is happening, but it looks a little bit different because of the different angle based on where the vanishing points are. And you can see it's closer, right, to the vanishing point over on the left. And so you can see it's a little bit more steep with how it's starting to concave into that vanishing point. The warpage is just a little bit more severe on that left versus the 45-45. It's basically isometric, or sorry, it's basically symmetric on both sides. And then you have 3-point perspective. So everything is vanishing again on the left, again on the right, and then below. And usually below, it's going to be much further below, so you're not going to see it as steep of a warpage below it, or potentially you can have it above it, right? If the object, if you're looking up at a worm's eye view. Because it's just, the vanishing point represents those different points the object is getting further away from you, and that's where it's causing the warpage. And usually below, you're just not going to end up seeing as much because it's just based off of the height. So now you have, for perspective cubes, something I wanted to show is, this is kind of how you measure everything else. So before I kind of was saying everything can be drawn inside of a cube. So if I want to cut this cube in half, I can draw an X inside of it. I know where the halfway marker is. I could do the same thing below it. I can keep segmenting different parts of that cube to decide where different parts of my drawing, my lines need to be. And if I need to project it out, the cube to make it even larger, which is what I'm showing over here, drew an X, drew it going through right here at the center point. And then I have a line going from here to where that met at that line and just all the way down. And that doubled the cube. Now it's not literally, this length is not on the right, is not twice the length as the original cube because it's being warped in perspective. Each time that cube is doubled in size, it's not actually doubled in length on the drawing because it's being warped, it's getting smaller as it's vanishing into those vanishing points. So a lot of times when you're doing technical drawings, you're going to end up using axiometric types of drawings. And for the most part, they'll actually be isometric. So you can see on the top, you have isometric, dimetric, and trimetric. And those are the three different types of axiometric drawings. For isometric drawing, all the angles are the same. So you have 30, 30 here. This is going to be the same. This is going to be the same. And if you look in the inside of the cube, 120 degrees all around. So you have everything being projected in the same angle. Dimetric, 2 different angles. Trimetric, 3 different angles. Again, almost always when you're using technical illustrations, you're going to end up using, especially if you're using axiometric, you're going to end up using isometric types of drawings. And that's because it doesn't have any warpage. And additionally, it doesn't have, you can make things more modular. So as this example from SimCity, all these buildings are drawn in isometric. I can grab this building on the bottom left, and I can put that in the back right. And it's not, I don't have to worry about perspective. I don't have to worry about where are the vanishing points and redrawing everything. That building is drawn to scale for that drawing wherever I place it. And if I need to make it larger, I can make it larger. But it makes reusing drawings much easier. Additionally, you can end up rotating it 120 degrees and just placing it on its different sides. And you can end up mirroring it. It just makes these drawings a lot easier to reuse the parts because they are isometric. And it's more of a true representation of what the drawing actually is, especially for technical communication, because it doesn't have the warpage that you do with perspective. So with perspective, you have ellipses. And so those are basically circles at an angle. And although I am showing this with circles, all objects are kind of going to follow, whether it's a triangle or a rectangle, it's going to follow the same types of ideas. So you can see with this cup, based on its angle, how much of it you're seeing. And so as it is rotated, the back is rotated up, you're able to see more of the inside, and that ellipse becomes more of a circle. And as it's brought down, it becomes thin. You can see on the right, Again, this would be basically at the horizon line. This would be basically, it looks like almost a thin line. And as it's moving up, moving away from you, the circle is, or the ellipse is becoming more and more circular, it's becoming more and more wide. And the same thing is true as it's going below. And so some more examples of ellipse. You have a major and minor axis. Again, everything can be drawn on a cube, on a rectangle. And so the major axis is always the long side, and then the minor axis is always the small side, and they are going to be 90 degrees from each other. So you can see top view, and this is an isometric cube. And then right view, and then left. And then you saw if you put them on all 6 sides of that cube, it basically look like a circle. And again, this is for an isometric cube. And then you have ellipse. So you can see as the ellipse is getting further away from you and is going into that vanishing point over on the right, it's actually starting to get smaller, but it's getting wider. It's becoming more and more circular as it's moving away from you. Now, over here, you see I did with 2-point perspectives for these. So again, as it's getting closer and closer to you, it's getting thinner. And then it's going to be getting smaller as it's going into that vanishing point, but wider. So again, everything can be drawn inside of a cube, and that also includes the sphere. So if you want to draw perfect circle inside the cube, you can grab the 3 major planes, which you see I drew in red over here. And then you can just draw an ellipse on each one of those planes, and then basically just connect them together. And so that was basically created a wireframe for it. This was done in a 3D modeling program for this sphere, and then to create a rendering, again, within a 3D modeling program. So next slide, you can see, actually, if you end up drawing it similar to how I was showing with the cube, you can draw 1/4 of it on each side, connect the lines, and that's how you end up giving a fillet. You rounded off that rectangle. And you can see how I did that with this drawing. And then I just kind of showed it similar, but with rendering. So everything has, if there's light involved, right, there's going to be shadows. And so typically with objects, this is being shown with a sphere, and each form factor is going to have different representation. Light's going to react with different form factors differently. And light can come obviously from multiple different directions, and can be different types of lights. It can be spotlight, it can be ambient light, and so forth. But typically with technical drawings, you're going to be showing it coming at an angle from above, because typically we see light come from above us. And so it's just more what we're used to. And you're going to see it come down. And on a sphere, you're going to have the highlight, which is going to be the brightest spot. And then as it's getting away from that highlight, you have a shadow on the actual sphere, right? And then as it's moving further from there, eventually you're going to have the darkest spot, which is going to be the core shadow. And as it moves even below that, right where it's about, right around where it's hitting the surface, and I made it a little bit brighter so you can see right here. Usually you're going to have, it's called a reflected shadow. And it's basically grabbing the reflection off of that surface, because pretty much every surface is going to have a reflection. Some might have a really high reflection, some might be very low. But light bounces off of objects. And then right where it is at the edge, you're going to have the cast shadow, and it's going to be the darkest right there. It's the least amount of light is going to be able to get close to that object onto the plane, on the surface plane. And then as it's light, as you get further and further from that object, more and more light is going to be able to get near it. Usually with technical illustrations, even if you are drawing it in color, very rarely do I draw cast shadows. A lot of times they just kind of detract from the drawing a little bit more and just a little bit more unnecessary. However, they are something that you can use, and there are certain times where you may decide that it does benefit the drawing to add them. So again, different types of form factors for objects are going to react to the same light source differently, even if they are made of the same type of material. So in the cone example on the top right, you have the highlight again, which is the brightest spot, and then as it's moving away from it, it's getting darker, right? And it's moving away from that main spot, it's getting darker again. With a cylinder, usually light comes from above, so the top is almost always going to be the brightest. And then again, you have that one spot that is the highlight, that's the brightest, and as it's moving over to the right, it's getting darker, and it's moving over to the left. Same thing with a cube. You have 3 different surfaces, so top usually is going to be the brightest. Because the light is coming from the right side is the second, and then the left side is the third. And again, all objects, right, have 6 sides. All cubes have 6 sides, but you're only able to see 3 of those at a time. Normally, if it's transparent or something else, then maybe you can see more, but typically you can only see 3 sides at a time. When it's at an angle. Then you have the sphere. Again, we kind of went through that. And then lastly, you have a tube. And so this one, right, you have the highlight, bright spot on the top as it's going down, it's getting darker. As it's going up, it's getting darker. And then inside the cube, it's not going to be getting as much light, but it's going to be very similar. That same spot is going to be the brightest, and it's going inside the cube, it's going to be getting, as it's going inside that tube, it's going to be getting darker. And then above it, as it's going up, there's not going to be as much light that's going to be able to hit, so it's going to get darker. Same thing below. And then the left side is just not going to be as bright as the top where the most light is hitting. Above it, I showed very similar. As you can obviously tell, the minor differences is that the flat surfaces, I wanted to let you know that technically light doesn't hit anything evenly, even if it is a flat surface. Light is going to be coming in at an angle. And so here, usually what happens is when light hits the surface, there's going to be that lip. And then that's where it's going to be the darkest, and it's just going to slight gradient. It's just going to slightly get lighter as it's moving away from that, and more light is able to hit that surface. And so same thing kind of happened with the cube, and then all 3 sides. So a lot of times when you're doing technical illustration, you're going to want to apply lines. And it's important to note that you can end up being able to further create depth within your drawing when you are using line weights by creating variations in them. So usually the ground line weight is going to be the heaviest. And then you have the outside border, which is going to be the second heaviest. And that's going to help that image really just pop or stand out. And then you're going to have anything that's kind of sides with depth. So anything you can really like put your fingers behind, or your hand, really anything that probably be casting a little bit of a shadow, is going to be the 3rd heaviest line weight. And then all the sides that you want to be able to represent. And so here I just kind of showed a line weight point that I ended up setting for this one that you could use, but is really doesn't have to be at those points. It just, you should use different line weights for different parts of the drawing. And then over on the left, I want to show that you can also apply reflection lines, which are usually going to be thinner. And then a little bit thicker than that, you'll a lot of times have contour. So if I didn't have these contour lines in here, then this drawing of a circle would literally just look like a circle. Because of this contour lines, I am showing the form factor of it as actually a sphere. And it's not just a circle on a page. So you can end up using lines to give form to your drawings. So within technical illustration and drafting drawings, there are a lot of different types of line types. And these different types of lines are going to have sometimes different colors. They are going to be broken up with dashes. They might be curvy, so on and so forth. And they are to represent different things or different parts of the drawings, right? So you have a visible line. That's what actually makes up the object. And then you can have dashed lines. So if you have something that's hidden, you want to show, such as the tube, you want to show maybe the inside that's hollow. You can be representing that with a dashed line. Hatch, if you end up cutting that tube in half, right? The hatch line is showing a cross section happening, but this inside doesn't have the hatch line because that part wasn't cut. The center line, so show center line of a drawing, is usually very thin. Dimension lines, again, usually a thin drawing, and you can just basically apply it to the outside to show the dimensions of your drawing. Visible lines, so if you're trying to show, you can see over here that you cut away at it. If you end up doing a cross section. Short break lines. So you see through the curves over here, if you're trying to break away part of that drawing, it's doing something similar to on the bottom left drawing as well. But usually with that one, you're going to be showing detail A, detail B, the short break line, usually more friendly for technical illustrations that are trying to represent more simple drawings and drafting, or may have to show a lot of different views and a lot of different parts. Basically just a break within that drawing. And then if you have long breaks, so you have a thick line, then you'll end up just a lot more sharp with how it's doing it, not as wavy. Phantom lines, so you show it's going from the object can rotate, it can move, it's usually very thin, it's not pure black, more of a gray. And again, it doesn't have to be exactly the same. You can change these some to match your drawing, your style guide. The most important thing is that it visually represents what you want to represent, and that you are being consistent with how you are using these lines, with how you're using these drawing styles. And then you have leader lines. So if you're pointing out at different parts, I like to a lot of times have different halos, especially if it is like a black and white line drawing. And you can see here, it's very thin, but I basically have a white halo on the outside of it that kind of just breaks apart the drawing and points out what I'm trying to represent or point out within the drawing. And then you have so some drawing examples that I wanted to be able to show that I thought were well represented within technical illustration. So these were done by a company called GTMR. And you can see you have different callouts. You can end up, these are all done in isometric as well. So it's very easy to reuse these different parts. You have, because it is technical illustrations, you can do detailed drawings where you can zoom into different parts. You can see on the bottom left, it's a little bit of an exploded view where you're showing how different things connect. Same thing on the bottom right. So there's a lot of different things that you can do because it's a technical illustration that makes it very easy to represent. On the right, again, different way to be able to project out different parts. So it's basically a antenna that's on part of the plane. And so it's showing a detailed view of what that actually looks like. Again, it's done in isometric. You can see how the angles are the same on both the one on the left and one on the right.
Adam, we have a
Yep.
question from the chat. Dave wants to know what kind of software you're using for these different drawings that we're seeing?
So these in particular that I'm showing right now, I used to work at GTMR. They have these on their actual website, so you can see them. For these in particular, Adobe Illustrator was used, but you can use a lot of different software that are out there. You can end up creating with 3D modeling programs as well. Corel Designer is another program that I've used, or Corel Draw. That's really great. But a lot of these drawings that I'm showing have been done through Adobe Illustrator. Are there any other questions?
So Dave says, interesting. I would have thought it would be 3D. Thanks.
Nope. Yeah, these were all done through Adobe Illustrator. And something to think about is, well, I guess a couple of parts to hit on that is Adobe Illustrator, as Dave mentioned, is primarily for 2D drawings. However, Adobe Illustrator does have 3D capabilities inside of it. So although I don't believe these drawings used any of those 3D parts, you can render different things out in isometric projections within Adobe Illustrator as 3D models. Usually the final output will still be a 2D drawing, but one thing that is unique with Adobe Illustrator in particular is that the 3D models that you can create and render out will maintain their vector elements. They're not gonna, you don't have to use ray tracing that you typically would use on with normal 3D modeling software such as Creo or SolidWorks or something in that nature. So if you are using Adobe Illustrator, usually it's going to be for creating vector drawings like I talked about before. And if you are using, if you're trying to manipulate raster images, then Photoshop is a great application for that. But there are a lot of other programs out there too. They're really just tools to be able to create what you need to represent.
Yeah, Jean in the chat box, she says Creo Illustrate from PTC does isometric drawings based on CAD data from Creo CAD modeling software.
Yep. I've used IsoDraw, and it's a decent program. There's a lot of different programs and tools out there, and a lot of them will be able to help you create isometric drawings. Now they have a lot of the professional software out there has for both 2D and 3D development has different presets to help you create 3D or isometric drawings, because isometric is just very common. A lot of times you're creating a technical drawing. Again, you want to create that in isometric because then you can end up reusing it. You make it modular. It doesn't have the warpage. It's just a very easy to visually represent. It different angles will look a little bit better or worse on average for components. And there are certain times we want to break from those norms. But isometric, for the most part, usually captures the object that you're trying to represent really well. So here's some renderings that I ended up doing. I used different 3D modeling programs to create them, and different rendering programs as well. But I wanted to be able to show different materials react to light differently, right? Glass typically is see-through. If it's hollow, right, the other side of the object that you're going to be seeing is going to be darker. It's going to make that part darker because it's basically less light is able to fully penetrate through that object. So you can see the top of this object on the left, you're only seeing one surface, and so it's a little bit lighter. Glass is usually fairly reflective as well, and so it's going to have certain parts where it's very dark and then certain parts that it's very light, depending on where the light is hitting it. It reacts with its environment. It takes in a lot of the light and reacts with its environment a lot. And same thing with screens, right? This is more of a chrome, so that's a very high reflection. The glass top left part is very dark. The bottom right part is fairly light. Glass screens, if you're end up needing to draw those, they take in a lot from their environment and are highly reflective. So usually we'll see more stark contrasts. You'll especially see that with anything that is chrome. A lot of times, because it's going to take in so much from its environment, you're going to be seeing a lot of different reflections from the objects that are around it, as well as the light sources that are being applied to it. You're going to a lot of times see very stark black and white contrast. And you can see that happening with these objects over here. And then you have matte finish as an example. So the same type of, if it's the same form factor, but the variable that's different is the actual reflective. So for here, matte type of surfaces, then it's going to be reacting with it very similarly. It's just not taking in as much from its environment. It's not going to be as reflective. You're not going to be seeing as much stark contrast within those objects, but you can still see how when things starting to wrinkle, they get darker. It's still taking in parts from its surface. It still has light is kind of rolling around it, and it has darker spots over on the left and lighter spots on the right, depending on where that light is hitting it. But it is not as stark or as much of a difference as you typically would see with a highly reflective material. So it's important to understand A, the form factor, but B, the type of material that you are trying to represent when you are trying to render out a drawing. And a lot of times when you're using rendering programs, you can further take them in. A lot of programs will actually allow you to export as a PSD or a Photoshop file. And so you can further manipulate it in Photoshop to make it look like you want it to be able to make those lights work the way that you think that they should. And so I wanted to capture some additional rendering things that you can end up doing. So in the top left, you can see I drew a button and I basically have it inset. And it's very simple to do. All this was just one color, and it was just a sequence of black and white applied to the outside of that rectangle, of that button, to be able to make it stand out, right? So again, light typically comes from above. Usually it's not directly above you. Usually it's at an angle. In this one, instead of having the light come from the right, I'm having it come from the left. But when you're doing graphical user interfaces, when you are trying to draw digital buttons, a lot of times you'll have it a little more stark contrast, and you see I drew black outline all around it. And as it hits the surface on the top, on the left and on top, it's white to kind of show that reflection of where the light is hitting that corner. And on the very other edge, it's dark because not as much light is going to be able to hit it. On the button in the top middle, I didn't draw the black on the outside of it. I wanted to show that just the button now looks like it's standing out from the surface below it. And again, all I did was put a white line on the top and the left and a black line on the, black line on the right and the bottom. This on the middle far left button, I made inset in. So I literally just did the opposite. Instead of having the white line on the top, I now have it on the bottom. And by doing that, you see the light being reflected on the bottom and on the right. And so it looks like it's brought into the actual object. And then here in the middle, in the drawing, I literally just created a circle, did the same sphere rendering like we had talked about before, and then made it very dark. So in the surface that's supposed to be coming up, that's going to be getting the most light, made the brightest. And then inside of that, it's going to be taking in some of that material from the blue, from that button. So I made it a little bit more blue. It's also going to be getting least amount of light because of that lip above it. And then below it's going to have a little bit more reflection, be a little bit covered up by the button, but it's going to be brighter because the light's going to be able to get in at it a little bit more. And then vice versa, below that lip, it's darker again. And so just by understanding light usually comes from above, how people are going to think about it, where is it going to be hitting each surface, you can end up creating a lot of different buttons, a lot of different types of objects. Here again, on the top right, I used a cylinder, same type of lighting, but I used a outdoor color scheme to kind of represent this. So made it brown like dirt, a little bit darker, it's getting lighter. Usually it goes up, lightest spot will typically be right above that, and then it usually gets darker as it's going to go above that for the outdoor regular dirt blue sky rendering. Same type of thing I did with the cylinder. And then on the bottom right, you can kind of see it, in the bottom middle, I gave more of a chromium, very high reflection, stark contrast between black and white, and then just a regular one with the sphere, just made it blue on the bottom left. And then lastly, I wanted to talk about Gestalt's principles of design. So really, Gestalt's principles can be applied to a lot of different things. Whether you're drawing a graphical user interface, you are doing an advertisement, even if you're doing a standard technical illustration, just understanding how different shapes, how different parts of a drawing react with each other, and then how that can create a communication, a visualization. So you can see here, the graphic designer used it to create a figure and then a ground. So you can see the wolf creates the figure, and then in the background, you have the face that works really well with each other. On the Coca-Cola advertisement, because of proximity, you can kind of see it all as just one smile, even though they're individual drawings. Similarity can be used to make objects basically work really well together, make everything feel the same and communicate one object. You can use similarity of fate. All the little birds are basically going in the same direction. It's redirecting your eye from left bottom down to that right, so you're following it. You use symmetry to be able to create your drawings. You can use parallelism to guide people's eyes to balance out your drawings. You can use continuity to create an object, or you can use closure. And it's being used as closure because you can see that the bear is not fully drawn in, right? The top of it is open, but your mind, your eye automatically closes those white gaps because of closure, because of how close everything is together. And so a lot of times in technical illustration too, although I always try to make things very technical, very closed off within technical 3D drawings, are representing physical components and not as much for graphics and logos, you can still have gaps in there and people's minds will automatically close those off. So thank you. Any questions?
So we'll remind everybody that you do have microphone rights. You can turn your mic on and ask your question out loud, or you can type it into the chat. And I just want to respond.
Yeah.
Adam, I was so impressed by what you presented today. And I'm struck with how much sort of brain science is involved. You know, your brain expects things to be a certain way, so they interpret the colors on the screen as a certain way, you know, making something 2D, vividly 3D, and all of the different ways that you've shown things receding, things coming toward me. I was really impressed with all this.
Well, thanks. It's really nice of you to say, yeah, it's amazing that you see these objects in your everyday life. And a lot of companies have now started using something called skeuomorphism, and they're actually starting to move away from that too. But your brain will automatically take things that it sees in real life and that it's used to, and then start trying to apply that to other objects. And that's really what we're trying to represent whenever we're doing visuals or doing drawings. It's not actually that object. It's not actually that graphic, but you're able to, if you understand the science, as you were saying, you can understand how objects react in normal life, what you normally see. You can apply those same principles to your drawings to be able to communicate to the user what they should expect. And with any types of gaps or any types of missing information, a lot of times that will automatically be filled in by the end user if you're doing it correctly, if you're doing the drawing correctly.
So we have a couple of comments in the chat. Krista says, wow. Wow. The more you learn, the more you realize you do not know. Thanks. This was like listening to a conversation in another language. And Dave wants to know, is your background in tech writing or design, and how did you become a technical illustrator?
So
take that one.
My background, as I said before, was in industrial design. I have a master's in business administration, currently getting a master's in science information technology. I have worked for a lot of different companies within the technical communication field. And honestly, there's pretty much nothing that I haven't done within the technical communication field. I've worked as a UX designer. I have worked as a service designer. I have worked professionally as technical illustration, technical illustrator, technical writer, multimedia designer. And a lot of it I was able to do because I always wanted to take on new things. Whenever I've worked at a company, they always need help with something, right? There's a gap that they need something to be figured out. And you can learn pretty much anything online, whether you are going to be Googling it, you're watching YouTube, you're using LinkedIn Learning or Lynda. There is a wealth of information that is out there. And personally, I'm just the type of person that just enjoys being able to bounce around, being able to learn new things and constantly grow. And I want to be able to solve problems and help out my company that I'm working for. And so throughout my jobs, I have just taken on new stuff and learned things on my own time just by studying, so I can be able to further grow within my fields. And so I got started off within my industrial design program that I got my bachelor's in, is a bachelor's in fine arts. And within that field, you have to be able to create, it's about communicating different products, different concepts. So you need to be able to do drawings, you need to be able to do 3D models, you need to know how to be able to physically build prototypes. And it's a very holistic discipline, but one of the things in there is very emphasizes drawings, being able to communicate to managers, to end users, your concepts, your ideas. And from there, I was started off with my internship at Gulfstream Aerospace Corporation. as a technical illustrator / graphic designer. And then I've worked at many other companies since then. And again, now I'm working at Mantech, and it is a phenomenal company.
Awesome. So we have a couple of comments in the chat. Robert says, very impressive presentation, Adam. Thanks. I look forward to digging into these topics in more detail. And Mike says he'll be thinking about the light source to improve his illustrations going forward. Very cool. Jamie says, great presentation, Adam. Thanks for all the cool info. It's amazing how art and science can merge together. So that's great.
Thank you.
And Julie has a question. She says, it sounds like you've used several 3D modeling programs. Which one or which ones would you say is the most helpful as a technical illustrator?
So to be honest, the one that I like the most as a technical illustrator, it's really going to depend on your intended output. So if it's going to be conventional, so I'm trying to think about the best way to answer it, because there's a lot of different types of answers. It really depends on your type of documentation. So let's say you are creating documentation using maybe Arbor text, you're using XML, using a FOSS and DTD, you want to create hotspots within those drawings. Well, Corel Designer is a great program for doing that. If you're trying to create different types of drawings, you want to have colors applied to it. I like to use Adobe Illustrator because you can maintain the vectors, assuming that your drawings will be able, your final output would be able to be kept in a vector format. But I try to not convert to for example, JPEGs or PNGs that are going to rasterize it. It's going to create as dots per square inch, and it's just not going to be as sharp as a vector object would ever be, because it's always going to be precise. Yeah, SVG would be for a final output. So SVG, CGMs, I like to use a lot, and they both have their pros and cons. CGMs will keep in a lot of that metadata. A lot of times, not always, there'll be a smaller file size. You have SVGs, and then you have SVGZs, which Z is basically the compressed form of SVG, and it stands for Scalable Vector Graphic. They work in a lot of different browsers, which is one of the benefits of SVG. CGMs don't work in as many, and it's not supported by Adobe Illustrator, but is on a lot of other technical drawing programs, such as like Corel Designer, IsoDraw, VisX Edit, things in that nature. So if you're doing, for example, technical illustrations where you're creating, you're allowing the end user to be able to manipulate 3D models, then there are also like PDC has Illustrate program where you're actually able to create animations. You can apply different effects to it, and you can build those into your procedures for the end user, so they can actually see things move, they can see things break down, they can move the drawings, they can create cross sections, they can hide different parts, and there's different formats that can support that, such as 3D PDFs, which is a U3D file format that the end user can view in Adobe Reader. So basically, there's a lot of different formats. Really, the first thing I would try to, or a lot of different tools that are out there. The first thing I would try to figure out is, what is your end product? How is the end user using that end product? Again, whether drawings are going to be the best for that, or if it's going to be video, it's going to be writing or whatever. And once you decide drawing is the best to communicate that, then try to figure out what tool will best support that. For the most part, I use Adobe Illustrator. It is a great tool for creating isometric drawings. You can easily apply colors to them, and you can make things modular. And that's just partially based off of the output. Not all of my drawings do not have hotspots. currently being applied to them, and they are not being viewed within a 3D format by the end user. But again, when those different when I know the end user is going to want to have those different types of applications, then I will shift to a different tool, a different program.
Well, that makes sense. And you have answered Mike's question. Mike asked, what about SVG format?
Yep.
And you addressed that. It also sounds
Yeah.
like Illustrator, because it's Adobe is a sort of a relatively common brand. It would be easy to find
Yep.
YouTube training.
Yes, that is true.
Yeah.
There's definitely a lot of great training out there for all pretty much Adobe programs. And that's not necessarily true with a lot of other softwares that are out there. And again, a lot of that has to do with the fact that Adobe does very much support that. There are different softwares out there that it's very hard to find information. A lot of PDC's products, for example, they are a very big tool, but I think they try to keep a lot of stuff in-house. And so I like their products a lot, but it is harder trying to find information on YouTube and things unless you're going to be paying for their training.
Yeah, they want to
And
sell
with
you their
Adobe,
training. Yeah.
Yeah. With Adobe, though, there's YouTube, LinkedIn Learning. There's just a wealth of information that's out there that is free and at your disposal that you can learn and pick up these tools on your own time.
Yeah. So Marcia says she's feeling challenged and enlightened, and she's going to re-listen to the video and maybe even practice. So.
Oh yeah, that's not a lot of this stuff. I mean, just from this presentation alone, you wouldn't become a perfect drawer, right? Like this is just to cover the basic concepts, the basic ideas. All this stuff, I learned the foundations over years, and then by doing lots of drawings to be able to communicate my concepts, and being able to produce it at a high fidelity, right? A lot of times when you are initially producing a concept, you can do it on a whiteboard, you can do it really quick and dirty, and it doesn't matter. When you're trying to do it for documentation, a final product for the end user, then that's where fidelity does matter. And being able to apply these types of concepts really just takes a lot of practice, repetition. And what I did a lot for myself is I would just grab pen and paper and I would apply it. I would just go over and over again. And I would try to create different form factors. I would try to create different types of drawings to try to make my mind think about it a little bit more. And at first, when I started drawing, I would apply the different vanishing points, or I would create the cube and be able to measure everything out. And as you get more and more comfortable with it, then you don't need that as much. You don't need to, but just try to practice doing drawings that are outside of your comfort zone, where you know you're going to have to learn as you're going through it. And it doesn't matter if you mess up. You're learning as you are doing it. And again, there's tons of information on different types of drawing, different types of shading techniques, lighting, so on and so forth, online. LinkedIn Learning is a great tool to be able to learn stuff, YouTube, Google, so on and so forth.
Well, fantastic. Well, I'm looking at the clock and I'm thinking, boy, this time has just flown by. People that are still in attendance, we will not be upset with you if you have to leave and go to another commitment. I want to, so we all have, yeah, so now people are typing in, thank you, Adam, one of the better webinars I've attended. Great, Mike. That's good feedback.
Thanks. Really nice to hear.
Yeah, I have learned so much. This was not at all what I was expecting. I'm impressed with how tool agnostic it is and how sciencey it is, and lots of good geometry. And I love math.
Yep. Yeah, definitely has plenty of mathy. Everything I do, I match out the, like, especially within Adobe Illustrator, you can do the precisions, you can do the polar coordinates. I match up all the angles. I make sure everything is precisely aligned. And again, that's really important for technical illustrations. Different types of graphics, it's not types, it may not be as important, but understanding the layout, understanding the form factor, understanding how that person's eye is going to be moving throughout the drawing or the visual graphic that you are depicting is really important.
So Adam, I don't know if you're reading the chat, but people are just typing in their thanks. Mike says, thank you, Adam. One of the best webinars I've attended. Mike says, great presentation. Thanks.
Oh, yeah, you're welcome.
I mean, Dave says, great presentation. Thanks. Krista says, thanks very much for a wonderful hour of learning, which definitely. Bobby Werner says, thank you. And Mike says, well, we have access to the recording. Yes. As soon as I get the recording uploaded to YouTube, you will get an email from Eventbrite with the link to the YouTube. So you can watch it again and again and again. And I'm hoping that Adam will share his slides with us, and I will have a link to the PDF of the slides.
Yeah.
And
yeah, I can definitely send you my slides after this this meeting, this webinar. Please let me know. And again, everybody, please feel free to reach out to me on LinkedIn if you have any questions, or again, if you end up checking out Mantech's site and you think you see a job that you're interested in and would be well qualified for, please let me know. And if I feel the same way, I'd be happy to try to do what I can to help and refer you.
Nice. Yeah, I have had friends that have worked for Mantech and they've really liked it.
Yeah, it's a phenomenal company.
Yeah. So I'm going to stop the recording.